Right now we have APT Attack Techniques in Azure Cloud by Lina. So let's welcome her to the stage.
Hello, testing? All right, awesome. Hi everyone, thank you so much for joining me. My name is Lina, or you can call me Inverse, as some of my internet friends call me. Today we're going to be talking about APT attacks in Azure Cloud. I want to set the scene a little bit and talk about why we are even talking about the cloud in the first place. As I'm aware, not everyone is in the red teaming or blue teaming space. I really like this write-up from Checkpoint, but essentially, since 2022, there's been a 48% increase in the types of attacks that infiltrate the cloud. Specifically in our region, in the Asia-Pacific region, there's been a 60% increase, so even more. The reason why this matters is because 98% of organizations are somewhat fully in the cloud or have some kind of hybrid model in the cloud. Now, this brings me to the problem and why we are even discussing attacks in the cloud. The first reason is there is a high knowledge barrier around what attack techniques exist in the cloud. Once you've worked your 100th business email compromise case, you can feel the soul leaving your body. But I'm here to tell you that there's more to life than business email compromise jobs and more to life than token abuse. There are a lot more attacks that infiltrate the cloud that aren't popularly known, and not many write-ups talk about it. The second reason is a lot of the remediations that happen after an incident response focus solely on the on-prem environment or solely on the cloud environment. Now, threat actors are evolving, so typically now what we're seeing with Black Cat Ransomware Group and ALPHV is that the way that they deploy their ransomware is now moving into the cloud space. For example, they're also encrypting storage containers sitting in Azure. The third is that there's a lot of misconceptions around the cloud, and namely these misconceptions lie around how strong MFA is. And I'm not talking about, stealing tokens or, MFA protects you, but more the fact that in the on-prem environment, we've got NTLM hashes, but in the cloud environment, we've got tokens. And if a threat actor steals a token, it bypasses the need for MFA. And then lastly, most organizations are fully in the cloud or hybrid, and threat actors know this, and they utilize this in their toolkit. Attacks in the cloud, it's not a thing that, outside of business email compromise, these more insidious attacks I'm talking about are already happening. I'm not going to go and talk about the history of each one of these threat groups, but just to give you a little TLDR. For example, Lapsus Group abuse techniques that allow them to persist in Azure AD, Entra ID, allow them to persist in Entra ID. APT29 loves to use lateral movement techniques like skeleton keys and golden SAML attack. APT28, also a Russian nation-state threat group, they like to leverage attacks that focus on abusing service principal accounts in Azure, or abusing OAuth 2 in order to persist inside the cloud environment. APT41 likes to do things like abusing legacy authentication protocols in the cloud. And I can't really talk about threat actors without talking about the big cloud elephant in the room, which was the Storm 0558 breach that Microsoft recently published a massive write-up about, and so did Wiz. This was where the alleged Chinese threat group found a crash dump in a Microsoft system where a race condition resulted in a signing key being present inside the crash dump. This allowed the threat actors to forge multiple tokens in order to access various resources inside the cloud. This resulted in the breach of multiple organizations in the government, various government organizations. Because I only have, unfortunately, 20 minutes with you guys today, I can't go into as much detail as I'd like, but what I want to give you guys is one example of an MFA bypass technique that involves token dumping that is not super well known, and this technique allows for lateral movement from the on-prem into the cloud environment. The second thing I'm going to talk about is on-prem to cloud lateral movement techniques, but I'm going to talk specifically about skeleton key abuse. And then lastly, we're going to wrap up the scene and talk a little bit about why do we care, where is it going, what can you do, it's not all doom and gloom. Okay, I think if you guys are on Twitter and if you work in IR or red teaming, you would have seen a lot of write-ups talking about token abuse or MFA bypass. What are tokens? Every single time you log into a resource in Azure, and by resource I mean things like Outlook, like Teams, like Yammer. I always use Yammer for some example, but I actually don't know anyone who uses it. Maybe some people do, I can hear some laughing. So what happens when you put your username and password and you approve the MFA token? Microsoft then issues you a token, and it's literally just a string that allows you and grants you access to the specific resource you want to access. The reason why this is a primary target for threat actors is because it circumvents the need for MFA. Once a threat actor has a token, no matter how many times you reset this person's password and reset their MFA, it doesn't nullify the access token. It only impacts the refresh token, which means the threat actors can still persist and log in as you, no matter if you changed your password 100 times. I really like this write-up from this security researcher called Mr. Docs. I've got the full link on the screen if you guys want to read his original write-up. But this is the technique. OK, every single time you open up your laptop and you open up PowerPoint or you open up Excel, how does this application know that it's tied to linalau@company.com? And linalau@company.com is the license for this product. The reason is, each one of these Microsoft Suite apps actually store an access token in the memory space of the process. And so conventionally, when we think about blue teaming detection techniques, even now, there's a lot of lexicon and conversations about, oh my God, look for dumping of LSAS, look at LSAS. But a threat actor doesn't necessarily need to go for LSAS if they're trying to infiltrate the cloud. They can create a dump of your Excel process. They can phish you. So let's say they phished you. They're on your PC. They can see you're talking shit with your friend on Teams, or they want to open up Excel, whatever it is. They target an Office executable. They create a dump of this process using the less sexy method of using Task Manager. You can use Sys internals tools. You can use run DLL32. You can look for any kind of lol bin that has a mini dump export function that you can abuse in order to dump out, create a little mini dump. Once you create the dump, all you have to do is grep inside the dump file for the string EYJ0, which is typically the starting point for something known as a JWT. A JWT is a JSON web token, and it's the encoded version of the access token embedded inside this process's memory. If you're a masochist, of course, you can use WinDebug, but there's no need. You can just grep it and look for this string. What you'll find if you go home or go to your job and experiment with this on your PC is you'll find multiple JWTs inside the application process. Once you iterate through the application process, you can use just like this website, jwt.io, and you can paste the string to figure out what this string even maps to, like what's this string for. So in this instance, you can see this particular token that I've taken pertains to access to Outlook. So I've gone on this person's PC, I've dumped out Excel. A blue team's like, oh, well, what's this person doing? Why is she dumping out Excel? I've taken the JWT, and it pertains to an access token to Outlook. And then from there, it also tells you the permissions. So now I know, oh God, I got Lina good. I can log in as Lina. I can send email as Lina. I can read Lina's mail. I can do whatever the hell relating to her inbox as per those API permissions. I'm not going to go read them all out to you. I think it's pretty self-explanatory what each of these APIs do. But if you think about it, the access tokens that you steal are not just for Outlook. It could be for Microsoft Graph. It could be for SharePoint. It could be for OneDrive. It just depends on what JWTs exist in the memory space. OK, now I want to steal all of Lina's emails. All right, let's use Microsoft Graph to do that. All I have to do is send a post request, paste in this token that I've stolen, point it at the Graph API for messages, completely bypassed MFA, and it will completely spit out all of Lina's emails. I've redacted it for obvious reasons because I tested this on a court machine. As you can see, I've dumped out emails relating to stuff from December. Pretty cool. Let's talk a little bit about lateral movement from on-prem to the cloud and some more sexy methods of doing so. There's three methods of hybrid authentication. Sorry. There's three methods of hybrid model setup that exist. You can use something called intra-ID password hash synchronization. You can do pass-through authentication, or you can utilize something called federation. Why do we care? Why am I sitting here giving you a system, sysadmin conversation around all these things? Because depending on the hybrid authentication model you pick, it leaves you vulnerable to a specific attack. For example, password hash synchronization. How this works is all your on-prem hashes are sent into Azure or synced into Azure. This means a threat actor can man in the middle the synchronization process and steal all the hashes in transit. The second method, pass-through authentication, means every single time I open up Teams in the browser, Outlook in the browser, whatever resource in the browser, I put in my username, put in my password, all the stuff I typed gets actually sent unhashed all the way back to a server sitting on-prem where there's a pass-through authentication agent that takes my credentials, by the way, unhashed in plain text, and then says, OK, yeah, Lina's password's correct, and then allows me to access the resources that I want to access. This method is vulnerable to a skeleton key attack. The third method, federation, is where you open up a browser and you want to access a resource. And this resource goes, OK, I'm now going to take you to your organization's login page. When this happens, you know you're in a federation model. This method of hybrid authentication makes you susceptible to an attack called golden SAML. Why am I even pointing this out? I've seen blue teams create threat hunting hypotheses in a federation environment looking for an attack on password hash synchronization. It completely doesn't even make sense. It doesn't match the threat model. So knowing what kind of environment you're in, especially when you're doing an incident response, allows you to gain insight into what kind of attacks even would apply. We're going to talk about skeleton key attacks. And the reason why I picked this attack to talk about today was because this attack was seen in the wild, leveraged by a Russian APT group back in August 2022. What these threat actors did was they created a backdoor that Microsoft named Magic Web. And on the right and left, are they flipped? OK. On the other side of the screen, I've got a Twitter screenshot of an awesome security researcher called Doug Beanstalk. I really recommend you guys follow him. I'm not sponsored to say that. I just think he has awesome research as well. What is a skeleton key? For people who work in blue and red team, you would be aware of the concept of a skeleton key when applied to LSAS. A skeleton key is simply a technique where you take a process and you backdoor it, aka injecting some kind of code into it that allows you to perform authentication. Now, how the skeleton key attack applies to pass-through authentication is a threat actor, instead of focusing on LSAS, they can focus on the Azure AD agent that performs the pass-through authentication. So the agent where every single person in the tenancy's passwords are being sent unhashed to. And the threat actors can backdoor this and sniff out every single password relating to all the logins. How does this work? First, a threat actor, so the pass-through authentication agent sits on the server that manages the authentication, right? And the executable is always called, and I don't remember this off by heart, Azure AD Connect Authentication Agent Service. That is the executable name that you look for. It's always called this. You take this particular executable and you inject a DLL into it. Unfortunately, we don't have time to talk about DLL injection methods, but you can inject your DLL into it and you can patch a specific API call to log on user W, which actually handles the whether or not your username and password is correct check. And then when you patch the function, it's going to run your malicious code. And your malicious code can do anything. It could go, let's store every single username and password in plain text. Let's add a secret password called I love frogs. So I can log in as any user in the tenancy with the password I love frogs, and it will automatically circumvent the authentication check. And then in order for the actual function inside Azure AD, I'm not going to read the whole executable name, in order for that function to continue flowing, it doesn't really need any information from that API call. All it looks for is whether or not authentication is correct or false. And so all you do is just forward the request on and then return the result. And it executes as per usual. And the method that you do that is this executable invokes a call to this Windows API key. This Windows API key we've hooked, and you can do this using an inline trampoline or whatever hooking method you want to use. And it runs our malicious code. Our malicious code then stores and man in the middle logs every single username and password that's ever typed in to access a tenancy, logs it into a file, adds it to a pipe, however you want to do the exfil, or you can add a secret password, and then literally just forward the request through to the next API, and execution flows as per usual. If you do not like to program and you don't like to build your own DLLs, my wonderful ex-colleague Nestori built an awesome offensive framework called AD internals. He's basically wrapped up everything I just said in terms of hooking this, injecting a DLL and hooking the logon user API. And all you have to do is run like install AD internals and just run install AD int PTI spy. And he just literally does, it does the whole process in the back end. But I do recommend building it out yourself because it's pretty simple to detect this tool. Now, what his tool does is it creates a hidden folder on a user's machine, and it will store all the passwords that someone ever typed into a little file. And in this instance, Henry is just sitting in his bed, sitting in bed, trying to access Outlook, 7 a.m., doesn't want to work, types in his username and password. That gets fed back through to the pass-through authentication agent. The agent's already backdoored by the skeleton key attack, and it's pushing and logging everything into a CSV file on a hidden directory that a threat actor can use and abuse. Actually, go back a step. The method that you can make this even scarier is, a lot of the times blue teamers think about detection very statically. Okay, technique 1, let's detect this. Technique 2, let's detect this. But they don't think about like, what happens if you chain multiple different types of techniques together? For example, a threat actor could take their little Kali machine or whatever machine they want to use, figure out what join this machine to Azure AD, Entra ID, and then download and install the pass-through authentication agent on their attacker machine, skeleton key their attacker machine, grift and steal, man in the middle all the passwords, and then remove this machine from Azure AD. You've now created a situation where there's an absence of logs pertaining to the skeleton key attack because the attacker has done it on their own machine, but what you can see are signs of malicious device join and maybe a download of pass-through authentication. Now, if you read about a lot of the write-ups centered around more of these insidious attacks like skeleton key and golden SAML, you'll come across wording and lexicon like ADFS could have been exploited. Skeleton key may have occurred. And the reason for that is the difficulty of detecting these attacks is paramount, especially when it comes to an attack like golden SAML, where the ADFS server, right off the bat, even if you enable verbose logging, will not actually log signs of you accessing the specific encryption key or exfiltrating the certificate from the system. These things aren't logged in the security event logs. They're not logged at all unless you enable 5 to 6 different manual things in order to detect it, which makes detection for this extremely difficult, especially when there's other techniques like a threat actor can spoof logs that actually show up inside Entra ID. And so now you've got, it's almost like a snowball effect, right? You do one technique, you add another one, you make it more complex, and now the scale of attacks that happen in the cloud now seem almost, it's very difficult to figure out what actually happened. So what is facilitating these techniques, and what can you do? So we've already talked about the fact that there's a lot of cloud adoption, everyone's moving to the cloud. We know this, but the issue with logs inside Entra ID is that there's a lack of clear definition around what impersonation means. On the Microsoft end, you see a token was used to log in, And the only method of figuring out if this is normal or not results in you having to focus on like really low-level IOCs like an IP or a user agent or something like this, but it doesn't give you contextual understanding of what's happened. And that's not Microsoft's fault, because on their end, all they see is a legitimate token was used to log in. So they are just displaying the information that actually is correct. Now, another thing is a lot of people on-prem or security teams don't think about the server, the AD Connect server. They don't treat it the same way as their domain controller. You know, they think of the DC as the keys to the kingdom, but your AD Connect server is the keys that grant a threat actor direct lateral movement straight into the cloud. And threat actors are capitalizing on the lack of knowledge and the lack of detections around it. Most of the detection rules and most of the conversations around the cloud, for some reason, are still centered on business email compromise and phishing and this kind of thing. It makes sense because it happens all the time. But these other types of attacks are happening. It's just there's like an education issue occurring. And then lastly, threat actors know that all your data is in the cloud. Like if you think about your normal day-to-day workflow, you're working on documents together with your team on OneDrive, maybe not OneDrive, like SharePoint, or you're doing things in the cloud, you're chatting on Teams, you're sharing documents in Teams. Threat actors know this. So some questions for you guys to consider, especially if you're in the blue team or in the red team. Not the red team, blue team, or you have an internal security team, are things like, what techniques is your blue team aware of? What techniques can you detect? And what is the level of logging that you have enabled in order to detect these attacks? I've seen multiple incidents where the incident responders go, OK, it's a cloud incident. Let's just look at the cloud logs, without realizing that if it's a hybrid environment, half of the context actually exists on-prem. And then lastly, thinking about what logs are actually being stored. I'll give you an example. There was a recent write-up by Wiz around Microsoft exposing a SAS token that allowed access to data stored inside a storage container. Entra ID audit logs will not tell you what someone accessed in a storage container. Neither will unified audit logs. This data is completely lost unless you have manually gone into the diagnostic log settings and enabled that audit level detail. So this is a little screenshot of an attack matrix that I built around 6-7 months ago that highlights every single one of the attacks that impact Azure Cloud or Entra Cloud. I'm still getting my head around it. Unfortunately, I'm limited in time, can't talk too much about everything. But I do have a training course as well that covers every single one of these attack techniques in detail, how to detect it and how to respond to it. Or you can just go on the website and download this for free. I've got this diagram everywhere. And with that, thank you guys so much for listening. If you've got any questions, I'll be around during the breakout side, so come say hi. Thank you.